So let me just stand under the light. Okay, so for those of you who don't know, I'm Jim Canaliato. I am the newly hired Director for Science and Technology here at ESI. This is our first tech talk. I guess we're going to start doing these on a regular basis. Not necessarily me, but this will be our first one. And I'm going to talk about 3D printing. How many people are familiar with or have a 3D printer in the room? Three of you? Okay, so you're somewhat familiar with it. All right, good. I got into 3D printing maybe about a year ago. I had this idea. I wanted to build clocks out of compact discs because I had all these compact discs all over my house, and I was like, what am I going to do with these things? Right? No one uses them anymore. So I just said, maybe I can make clocks out of them. And I started to tinker with it and try to different ideas, and sort of encountered some issues. How am I going to assemble and build these things? Because it's not just the CD, right? You need more than that. And so I thought, well, maybe I could use a 3D printer to help me do that. So I got one, and I started to fool with that. And on this table here are various components that some of my work that I've as I progressed through my clock project that I built, and then I started to learn more about it and made other things. So this is a bracket that I built for my tablet in my car. In fact, I'll show you how that works real quick. I wanted to use Google Maps in my car, and of course you don't want it lying on your louder. Oh, is this on? Is this not on? It is on. Can anybody? So I need to be louder? All right. Gosh, I feel like I'm really talking loud as it is. Anyway, so so I built this little bracket that you snap on to the tablet like this, and then it literally just goes right into the dash. I can show you a quick picture. Like that. And then I can just use Google Maps, no fuss, no muss, and I don't have to worry about it slipping off my lap. So yeah, I found it very useful, and I can, as I go along, I'll tell you other things that I've done as well. So for those of you who are not familiar with it, what is 3D printing? It's basically a fabrication method, right? It's a way of manufacturing objects. I don't really like the word 3D printing because it conjures up visions of 2D printing or regular inkjet printing or laser jet printing, where that's a very mature technology. It's a very reliable, very convenient. You just have to feed the printer paper, and you have to feed it toner or ink, and it works, right? You don't have to do anything else. 3D printing is nothing like that. It's much more involved. There's a lot more issues you have to deal with. Prints can go bad. The different materials, there's different. I'll get into all that, but there's a lot of different issues you have to deal with. Maybe someday we'll get to a point where it's as easy as a laser printer, but not quite yet. So the history is it's actually been around quite a while. The first patents were in the 1980s. The first technique was called stereolithography. It's actually a technique where ultraviolet light is used to cause resin material to cure on contact with the light, and by creating basically a scanning system. That was the first type of 3D printing process. But then later on, other techniques started to come out, like FDM, fusion deposition modeling, which is how my printer is based. Selective laser sintering, which is how you do metal 3D printing. And the thing is all these patents associated with these different techniques started to expire maybe about late 2000s, right? So like the FDM patent expired in 2009, and that ushered in this whole flood of consumer products and cheaper products that came into the market. I went to Maker Faire probably. My first Maker Faire, maybe 2011, and saw my first 3D printing when I was there. And let me tell you, it was terrible, just horrible, right, back in those days. It's come a long way since then, and you can actually make useful objects. Still not as easy as inkjet printers, but it's come a long way. So this is, even though I don't like the term 3D printing, these are the terms I do like. So subtractive manufacturing, additive manufacturing, and rapid prototyping. So subtractive manufacturing is how we normally make things up until the advent of 3D printers. So that's basically where we take a piece of stock material like metal or wood, we cut it, we drill it, we basically subtract material away from it until we get the thing we want. Additive manufacturing is basically the opposite of that. So we're going to add material onto basically nothing until we get what we want. And it's quite a bit different approach. And the thing about additive in the 3D printing world is that the processes are such that you can make things you just can't make any other way. And there have been examples of that now that 3D printing has sort of gotten into the industrial manufacturing world. They're actually now starting to use it to make things that they couldn't make any other way. And then, of course, rapid prototyping, the big application for 3D printing and additive manufacturing was rapid prototyping, because I can design something in my CAD tool. If let's say I'm building an airplane and I need to build a model and I need to do wind tunnel testing, I can print it and test it very quickly with a very short cycle time. Whereas with previous techniques, that was a much more difficult proposition, right? It took a lot longer for them to do those kind of prototypes. And then if I want to change something, very easy, make a change, print another one. And then you basically can, you can see how that could be a very quick cycle time. So this is just a little diagram to try to illustrate the difference between subtractive and additive. So here's your block of material, and I'm basically taking this material away somehow, either through cutting or some other process to get this. Whereas in additive, we're going to take a model of an object, and we're going to create it, turn it into layers, and then we're going to manufacture each layer and then fuse them together to create the object. So how does this actually work? So you start with a 3D model. There's a lot of different ways to make 3D models, and I'll talk about that in a minute. But you can kind of think of it as the source document of a 3D printer, like a Word document or JPEG or something like that. That's how you start. However you make your model, and there's a lot of ways to do that, you need to produce what's called an STL file. It's sort of the standard data file format that most of the 3D printing tools and 3D modeling tools either export, import, or process. STL actually stands for stereolithography, so it's sort of a holdover from that first 3D printing technique. Then you take that and you run it through what's called a slicer. And a slicer literally does what it sounds like. It's going to take that model that represented by the STL file, and it's going to turn it into layers, right? And those layers are then going to be used to, or that processing is going to be used to create a command set that is processed by your 3D printer. There's a whole language that the printers understand that makes the heads move and everything work. And in fact, your inkjet printer and your laser printer have a language like that too. It's just you never see it, right? It's like PCL and PostScript and other languages that are used to drive printers. We've gotten to the point where all that's buried under the covers, and the device drivers do it. In the 3D printing world, you can't. We're not there yet. You have to be. All that has to be visible. And then the additive manufacturing process, which is like a printer like this one, will then produce that object. So the first thing you need to do is you need to get a 3D model. So how do you do that? So there's 4 different ways to do it. First of all, you can create them yourself using 3D modeling software. So over down here in the corner is a picture of a piece of software I've used called Autodesk 123D. There's a ton of these tools out there. There's Autodesk Fusion 360. There's Blender. There's something called Tinkercad, which is like a web-based. You can use your browser to build models. and there's others as well. They're all oriented toward making your model. Now, there's sort of two different universes in 3D modeling. There's the artistic universe, which is, if you're making maybe miniatures, or at the beginning I had that they was printing that picture of Batman, things like that. There's that world, and then there's the engineering world where you want to build, like a bracket for your tablet, right? That's a more engineering style, and there are tools that are better for one or the other, and some of them do try to do both. Then you can also scan an object using a 3D scanner, which looks like this. So you put an object onto the scanner. It has a little turntable. It has a laser, and the object spins around, and it basically takes a scan of the entire object and turns that into a model. So you can reproduce something you already have using that process. Then there's this interesting thing where you can take ordinary pictures, 2D pictures. If you take enough of them, and different angles of the thing you're trying to create a model of, and basically create a model out of that. So here's there's a little model dinosaur here, and I don't know if you can make it out, but it's basically taking pictures at different orientations around that object, and then those can be stitched together into a model. And then finally, if you don't want to do any work at all, you just want to get a model, there are websites like Thingiverse where you can basically go on there and you can search, and there's plenty of people out there that are making models all the time and uploading them into the internet on these different websites, and you just search for the thing you want. And in fact, this Christmas ornament was something I downloaded off of Thingiverse and printed on my printer over the holidays. So that's a much easier way to do it as well. And you can also download them and modify them if you're so inclined. All right, so once you've got your model and you've exported your STL, then you need to slice it. And basically you take an object, you turn it into layers, and then the slicer generates the commands to the printer to produce that object. However, the world's not quite that simple, because there are certain geometries that the printer is not going to be able to handle. And really it has to do with what they call overhangs. So like here, this little overhang is fine. The printer will handle that just fine. This is getting close to a 45-degree angle. You could try it. It might droop a little. It might not look so great, but you may be okay. And then over here, this angle is such that the material is going to droop when the printer head moves over it. So you have to then tell the slicer, please add support so that this doesn't droop. And so this is an example of a slicer called Simplify 3D, where you've actually said to the tool, please automatically add support. So it did that in the middle picture. And then you can selectively remove support and only basically hone in on the things you really are concerned about, because support, it's kind of a double-edged sword. You need it for this kind of situation, but you also have to remove it when the print's done, and then you have to clean up the print. So the more you have, the more removal and cleanup work you have. So this gives you a way to control that. All right. So then you've done that, and then you actually send the print to the printer. The language that the printer understands is called G-code, and it came from the CNC milling world. So the 3D printing world borrowed that same language, and then you just have to load the G-code onto the printer, and then it will execute it. It doesn't know anything about the print, right? It's a dumb machine. So it's simply going to move and extrude material in the sequence commanded by the G-code, right? So what that means, if something bad happens while it's printing, for example, let's say the print comes loose from the bed, right, and it moves around, the printer's just going to keep spewing material onto the bed, and it can turn into a spaghetti mess, right? And it'll do it until it's done, until all the commands have been exhausted. The print can also warp, right? I've had this happen, and then it changes its position slightly, and then you get problems with that. So there are, like, I know that there are programs, like for my printer, you can get a camera that you can attach to it and then stream the video to the internet so you can watch the print while you're going about your business, because, you know, these prints can take a while, hours sometimes, so you might want to watch it. And then if it's messing up, you can remotely command it to stop printing so you're not wasting your material on a failed print. But one of the decisions you have to make when you run your slicer is the layer thickness. How thick will each layer be? A very, very narrow layer, like 1/10 of a millimeter, will produce a very clean, very nice print. However, it will take a long time to print because it'll have more layers on which to produce. I typically will go with 1/4 millimeter. That seems to be a good compromise, but it depends on what you're going for. There are some prints that won't print at 1/4 millimeter. You have to go narrower. And then if you really are in a hurry, you could do more than that. You could do 1/2 millimeter or something like that. And then there's finishing. So you've done your print. It's off. It's now, you remove it from the printer, and you're still going to have a little, you do a little bit of subtractive manufacturing at this point. You may have to trim it. You may have to sand it, polish it. There are finishing baths you can use. So if you use a material called ABS, you can create what's called an acetone bath. And when you do that, you get a shiny coating, like on this ornament. It's actually got a shine to it. You can also, if you have support material, you may have to remove it, physically remove it, and then there's also techniques where you can immerse the model in a solvent, because you've used two different materials. You've used one for the support and one for the object. And some materials they actually dissolve nicely, so that way you have less work to clean up your print. Okay, so I'm going to talk a little bit about these different technologies. There's a lot of different printing technologies out there. I don't have time to talk about them all, but I'll talk about these few here. The stereolithography I mentioned at the beginning. So you've got this resin that's in this basically like a tub. It's liquid. You've got a platform that can be moved up and down, and then you've got a ultraviolet laser and a scanning system. And then when the laser touches the resin cures. And so it basically traces the shape of that layer across the surface of the resin, and that cures a layer, and then the platform moves down, and then it does it again, and then it does it again until the entire model is built. Second method I'll talk about is the SLS process. This is the process used to do, one of the processes used to do metal 3D printing, which you can do. So there's a metal powder that's on in a area on the left, and then the objects were created on the right. And what happens is there's this recoder arm that sweeps a bit of the powder onto the build platform, and then a high-powered CO2 laser comes in and literally melts the powder at various points on the object, and that fuses it together. And it does it layer by layer, and so in the next, this moves down and this moves up, and then it recoats again and does it again. And as the object gets created, as this build platform moves down, what happens is this fills up with powder. So you get the object is basically buried in this powder. So when the print's done, you have to go and dig it out and then clean it up. And then the final method is the method that's used by a lot of my printer and a lot of the consumer grade printers, and that's FDM, fused deposition modeling. And basically what happens there is there's a nozzle that's heated to a high temperature, and then you put in a material, what they call thermoplastic material, which has, when it melts, it flows very, very cleanly, and then it has a very fast cooling process where it'll turn to a solid. They call it a glass transition, where it goes from a liquid into, or a molten level material into a solid very quickly. And the printer will basically put layers down one at a time onto the build platform, which is on my printer this is the build platform, and then this is the nozzles over here. And then as the model gets created, it'll do each layer one at a time. So let me, I'm going to fire this thing up and get it warmed up, because so since it's all based on heating, it has to have time to prepare itself. So I'm going to actually run a print when it gets heated up. There's actually two things that are heated on the printer. One is the nozzle where the material comes in. So this is the material, and I'm using a PLA plastic. And I'll talk about different materials in a minute. It follows this path into the print head, and then there's a separ motor and a basically a gear system that draws it into the nozzle. It melts, and then it's deposited out through the bottom here. The other thing that's heated is this, the build platform. The build platform, there's a couple of neat things that it needs to do. One is the material has to stay adhered to the platform while it prints. And there are some materials that warp when they cool. So like ABS, for example, will do that. So keeping the platform warm keeps it from warping too much. And then the other thing is just the general adhesive properties of the bed. Now I have a bed it's called PEI, polyethermide something or other material that's very good for this kind of printing. Without that, and believe me, there were times when that kind of technology didn't exist, people would do all kinds of crazy things to get their print to stick to the bed. They would put tape, they'd get that blue painter's tape, and they would cover their build platform with tape to get it to stick. Or they might take hairspray and spray it onto the build platform, or literally glue. They would take Elmer's glue and smear it all over the build platform. Those are the very difficult days for 3D printers. With this PEI material, you don't have to do any of that stuff, and it will print nicely. Now you do have to worry about setting the printer up. My printer has it's all manually configured, manually adjusted. So the distance, for example, of the head to the bed, right? There's a gap there, right? That has to be set. I have to set that, and I have tools to do that. The bed also has to be level relative to the nozzle. So every point, right, has to be, because we're talking fractions of a millimeter here. It has to be really, really close, and you have to be very careful. If you get it wrong and the bed's just even slightly off, the print will not come out good. Newer printers are starting to introduce self-leveling and self-cleaning technologies. So like this is a TAS 5 printer. The TAS 6 is self-leveling, which if people, it's great, right? You don't have to worry about it. It actually will touch the corners as this little sensor, and it touches all 4 corners, and then it mathematically figures out where the leveling is. So if you're going to buy a printer, I'd recommend getting a self-leveling printer and one with a PEI bed. So that's the moral of the story right there. Now, what kind of materials can you print with? So these are all the things that my printer supports. So there's an ABS plastic. It's a pretty tough material, pretty good. This is made out of ABS. It flexes nicely. It's hard to break. It doesn't melt at low temperature, relatively low temperatures, but it does tend to warp, and it does sometimes have adhesion problems on the bed. So you have to make sure you're careful with it. Then there's PLA. This is PLA here that I'm using for this print right now. PLA, the general conventional wisdom about PLA is it's the easiest thing to print. It's relatively lower temperature. It adheres nicely to the bed. You can even print it on a cold bed. The only kind of the downside of PLA, I guess it's also biodegradable, so it has an environmental advantage. The only sort of downside is it's brittle. It can break. You don't want to use it in any scenarios that are going to be under stress. And if it's in anything really hot, it will melt. It has a lower melting temperature. I won't go through all of them, but the idea is that you get different properties and a different look, right? So like this tea glaze here is very shiny. Prints with that. Ninja Flex is flexible material. You can make phone cases out of it. You can make watch bands out of it. Then there's all these here. I have a spool of this wood filament here that I printed. So I printed a clock face. This is printed with the with that filament, and then I've got some of these ESI items that I printed. You're all going to get. You can take one of these when you guys leave. So there's 3 different materials I've used for these ESI logos. Okay, so there's this one here is using the wood filament. All right, and that actually came out really nice. I'm really happy with that one. This is PLA, white PLA, which is same as the printer right now. And then this is the HIPS, the high impact polystyrene, blue. Just to give you an idea. Now, you can kind of feel like this one. It bends a little. This one doesn't, because the PLA is very brittle. I could break this very easily right now. It's stiff. And then this is also a PLA, but it has a wood. They take PLA and they mix wood fibers into it. Is how they do that. You can make all kinds of interesting things. If you go online, you look up some of these materials, and some of the things people have made, it's kind of amazing. Especially these wood, bronze, bamboo, and copper. The people have done some amazing stuff with it. Okay, just to give you a sense for, there's lots of printers out there, right? This is mine. But there's ones that are as big as people. There's enclosed, like this. Mine's an open design, but there are enclosed designs as well. Some are very small printers. This is actually considered a fairly large printer for home use. Has a fairly large build platform. Most printers are smaller than that you'd find at home. But all these are different factors when you're looking at buying one that you look at is how big, what's the technique. Like some printers only handle ABS and PLA and that's it, right? So if you want to print some of these more exotic materials, you have to look into what the printer is capable of. Okay, so how is 3D printing actually used in the real world? And the truth is that it's starting to really gain some traction. So in the industrial world and medical uses, aerospace, it's growing. And this little diagram here gives you an idea of how the different uses of 3D printers have grown over time and where they're going. Like in the early days, it was all about rapid prototyping. Then people realized, we can use these to build molds and other tools. Digital manufacturing is sort of growing now. And then this personal fabrication, where people will be able to make their own stuff easily. Still a little lagging. I mean, if this is the adoption curve, anybody who's got a 3D printer today is pretty much an early adopter, right? They're on early adopter curve. Things are still early. Medical applications. So 3D printing has actually become really big in medical because we're all different. Our bone structure, our bodies are all different, and so when it comes to making prosthetics, implants, and other types of things that we might use in our bodies, we can use a 3D printing process to make them exactly fit our bodies, right? And so, for example, this thing here, I guess this is an implant, or I guess we call it an implant. The hearing aid industry is almost 100% now 3D printed. They take a mold of your ear, and then they actually make a custom fit 3D printed insert for that hearing aid. So I think that it's really been a big win for medical. Then in the industrial, it's getting uses. So GE has a division dedicated to additive manufacturing. And just to see if they could do it, I guess, they took and built a model jet engine. It's about as big as a football, out of all 3D printed parts. And then they tested it, and it actually worked. Right? It got up to 33,000 RPM. It actually produced thrust. You can, if you want to see the video, you can watch it there. And then for actual commercial jet aircraft, GE has created a jet nozzle that's used in the Boeing 777, which actually gives them significantly higher fuel performance. And the fuel nozzle could not have been manufactured using regular techniques. And in fact, not only is the geometry of an internal structure of it very unique, it's only like 3 parts. And so whereas the previous nozzle was like 50 parts, right, that had to be assembled. So they were able to dramatically shorten the assembly time of that part. Audi, when you think about a car manufacturer, if they make a car, they're going to have to worry about making spare parts for the next 10 or 20 years, or maybe even longer. And so that's a big deal, right? They have to manufacture them, they have to stock them all over the world. So Audi has started to position 3D printers at locations all over the planet. And if parts are needed, rather than manufacture them ahead of time and stock them, they just 3D print them as on demand, as needed. And then Honda is starting to use 3D printing as a way for people to allow them to customize their cars, right? So if you have a specific design for a wheel or a specific design for other trim on the car, they will actually let you put that on the car when they build it for you. And then the craziest thing I've ever seen is 3D printing for making buildings, okay? You can watch the video, it's just unbelievable. They've built this giant, basically 3D printer that extrudes like a concrete looking material, and it makes walls and in building structures the same way my printer extrudes plastic, right? But it makes it at a giant scale. If we have time, I could show that video, but check that out. Okay, the dark side of 3D printing. So, nothing is without its dark side, I guess. So, this guy Cody Clark, I think that's his name. He was the first person to print a working 3D gun. I think it only shoots one shot. It's not a sophisticated gun. I don't believe there have been any crimes committed with 3D weapons, but the fact that it was even possible got people thinking, right? So let's say in the future we're able to actually produce objects in our homes, or even down the street, the local 3D printing shop or whatever, and we can print a gun. Well, think about that. It's totally untraceable, right? Totally untraceable. You could outlaw them, right? You could pass laws and say no 3D printed guns. That's not going to stop anybody, right? Because they can just print it in their house and nobody will know. So the people are concerned about what could happen. I don't think it's a big threat yet, but what could happen down the road. Another interesting case was 3D printed master keys. So TSA in 2015 proudly announced that they had a whole new set of master keys for luggage. They have that so they can look at your stuff at the airport when you check your baggage. And they actually posted the pictures of the keys on their website. Well, some enterprising hacker, I guess you could call him, 3D hacker, took those pictures and actually 3D printed the keys, and now he's got a set of master keys for all luggage. And then the third case is where they've been able to, they've found, I don't think this has happened in the United States, but it's happened in Europe and it's happened in Australia, where they've created very realistic looking what they call skimmers, right, to basically cover the actual surface of the ATM machine, and it looks to you, it looks perfectly fine. And then you stick your card in there, and it reads your card, unbeknownst to you, right? And so they've found these devices and pulled them off, and are trying to control that problem. And then finally, so some of the possibilities of what could happen in the future. So first of all, additive manufacturing is it's simply cleaner, it's more economical, it's more efficient. Subtractive, there's a lot of material wasted, right? All that drilling and cutting that you can try recycling it, but the truth is it's better to just use what you need rather than cut off and throw away a lot. The future of just-in-time manufacturing could really be extended now. The idea, like what Audi's doing, no inventory. Everything's just built and printed on demand. There's people just make what they need. Customization and complexity are nearly free. So looking at the medical industry, looking at other, we could. Right now, the world, the subtractive world and the industrial world's all based on, making exactly the same thing over and over and over again in millions of units, no customization. Well, 3D printing gives us the possibility of customizing and making things very specialized, very unique, and doing it without a lot of cost. And then the complexity issue, just doing things we just couldn't do before. Like that jet nozzle for the 777 jet engine. They couldn't make that any other way other than using additive manufacturing. Multi-part assembly is reduced or eliminated. So when I was doing my clock project, I started out with this idea. I had an idea where I had a RGB LED ring inside, and then I was going to use the two CDs, and it would shine through, and I would have a gap, and I needed a way to make a gap right between that, so I could put the LEDs in there. And when I first tried it without the 3D printer, I actually cut a piece of wood, right, with my drill press, and I broke my drill press doing it because it's a little baby one, and it's not really designed for that. So I was like, well, how am I going to do this? And I got the printer. I was like, I know, I'll 3D print. 3D printer can make circle things really, really well. So this is what I printed. And I even put little holes in here for the screws. And so what I had to do is I had to drill holes into the CD on one side and screw it in, and then on the other side I would glue it. And I thought, oh, that's great. And then it dawned on me. And then I was going to put this on the back for the electronics, right? That was my design. And then it dawned on me, I don't have to do all that. I can 3D print a lot of it. So this is what I finally ended up with after several iterations, where basically the enclosure for the electronics, the CD on the back got eliminated. I basically 3D printed that whole part. All the holes I need for all the different parts of it are just included in the print. I've got little holes for my PCB board. I put I put the RGB LEDs here, right? I glue them in. I put the CD on top, like this, and then I put a clock face on it. And this is sort of what it looks like. This is the final result. There's no screws in this, right? So in terms of assembly, it dramatically simplified my construction assembly. I don't have to do all this drilling and screwing and other crap. So it's all simplified. And then manufacturing returns home. So right now, a lot of manufacturing gets outsourced, outside the United States, and the advent of this kind of technology might bring all that back someday, right? Where now we're doing manufacturing in our house or in our local towns or whatever, because everything's so customized. All right, so some technologies that are looming on the horizon. So there's a company called Carbon 3D that has pioneered a new technique called CLIP, the Continuous Liquid Interface Production. And so what they did is they took stereolithography, which I explained with the UV laser, and they added they call it a dead zone, where they're using oxygen as an inhibitor. And this technique now allows them to finally control the curing process of the resin. And that, in turn, enables them to create parts which are as good as injection molded parts and even better in many cases. So it's a technology where they're now the layers are operating literally at the molecular level. And when you watch the video, it's like literally, if you guys watched Star Trek and seen the replicator technology they have, it's like that. Okay, it's really amazing, and it's also really fast. So when I print stuff on my printer, it could take hours to print something. This thing printed a little model of the Eiffel Tower in like 10 minutes. I mean, it was unbelievable. So I think that this is a sign that the technology is going to get there. It's going to get so good that everyone will just have to use it. Bioprinting. There are universities out there that are experimenting with, instead of using a plastic or a metal as a material, they use cells as a material, and they're layering cells, and they're literally 3D printing organs and other kinds of biological objects. And then finally, nanoprinting, where they're layering things at the molecular level so that they can make batteries the size of a grain of sand. So if you think about nanotechnology and nanobots and all of that, well, you're going to need teeny little batteries. So they're figuring out how to do that using 3D printing. So it's going to be an interesting world in 10 or 20 years. All right, so let me fire this thing up. A little bit of leakage there. So you don't want to touch the nozzle because it's at 209 degrees centigrade. All right, I'm going to just make sure it's pretty clean. Okay, so first thing it does is it homes itself to the corner so that it knows where 0 is. And then it'll pull in and it'll start doing the print. This will it's basically going to print one of these things. I guess I could pass this around. You guys want to take one? Now, first thing it does is it primes the nozzle, which will probably take a little bit. It's a little bit of materials coming out now, and then it'll start actually printing the object. So that's pretty much it. Are there any questions?
You mentioned about the electronic manufacturing, so what capacity electronic?
Yeah, so I didn't really talk about it much. There's something called conductive filament, and there are machines that can actually 3D print circuits. When I was at Maker Faire, a guy came up to me and talked to me about that because some of the circuits I'm using could be done that way. So that's another thing that could happen. I mean, and I guess in a dream world someday you could imagine you print and it makes everything, right? It prints the structures, the enclosure, the circuit, the whole thing, and then you get a completed object. The one thing about this printer and a lot of the FDM printers is I only have one nozzle, right? So I can only run one material through here. I can get this. One of the nice things I like about this printer is I can take this head off and I can replace it with another one, and I can get a head with 2 nozzles, so I can run 2 different materials. That's the most that I can do, though, right? So if you wanted to do something really sophisticated with a lot of different materials, you would need some crazy machine that I can't afford. So, any other questions?
Can I ask what this machine goes for?
This was about $2,500. The reason I bought it was, like I said, I like the head design. A lot of the parts on this printer are 3D printed. The company that makes this has like a factory of printers like this, where they just have them running all the time, making parts to make more printers. All the designs for the Lulzbot class printers are online. They open source everything. So if anything breaks or I want to do an upgrade or anything like that, I can use my printer to upgrade itself. So I think it's kind of cool. I can also, like I said, I can replace parts that break as well, which is also very cool. It has a 300 degree nozzle, so that enables it to do a lot of different kinds of materials. It's 0.5 millimeter, so that, you know, like the wood fill, it will work with it. And, so it gives me a lot of flexibility. It is kind of big. Like now, they have a model called the Mini, which has like a 6-inch instead of a 12-inch bed. It has a 6-inch bed, and it also has self-leveling, and it's quite a bit cheaper. It's like less than half the price. So if you wanted something that was you know, easier and a little smaller, still people love the Lulzbot Minis. Actually, they do love them. That's a good one to look at. Anything else? Yeah.
How available and expensive are the materials themselves?
Yeah, the materials do vary in price. So PLA is probably the cheapest. You know, you might get a spool of that for what, $25 maybe? 20?
Yeah, depending on
20?
manufacturer. There's a couple on Amazon.
Yeah, I mean, they're like the eSun is cheaper than like the Village Plastics. Depends on the you know, who you're getting it from.
You can also come up.
Yeah, if you guys want to come up and watch the printer, it's kind of cool to watch.